welcome back to Max Lecture Series. In this series, we are learning how to obtain the solutions for higher order differential equation. So, we observed that higher order differential equation will be giving two type of solution. One is complementary function, another one is particular integration. Anyway, we know particular integration will be existing only when the right hand side of the differential equation will be not equal to 0. Something should be existing there. But here if you observe in the given differential equation, right hand side is 0. So, particular integration will be 0. Now, how will you write down the solution? As usual, numerator variable will be considered as dependent variable, denominator variable will be your independent variable. So, the solution is dependent variable is depending on independent variable y of x equal to, we will be having two solutions, one is complementary function plus particular integration. Since the particular integration is 0 in our case, because right hand side is 0, we will be having only complementary function. Okay. Now, while writing the complementary function, we saw first case we saw the values are not same. Sometimes we will be having purely real values, but they are different. Then we understood, okay, if the roots are real and different, we understood how to write down the solution for that. Suppose, sir, roots are real, but what happened? They are same. When the roots are same, then we observed that how to write down the solution. Okay, sir. So, if the roots are purely real, whether it is same or repeated, now we understood how to write down the solution for that. Suppose, let us take the one more question. See there. The given it is d square y by dx square plus 4y equal to 0. What I did is, I have started solving this. We know this d square by dx square will be replaced by d square, capital D square. Then directly here we will be having only 4y. I am directly writing the solution, first step. After that, in the second step, since we have common variable here, that is dependent variable, we can take it out. After that, we can observe we will be obtaining one polynomial expression. After that, take it out, just equate it to 0. If I will resolve it, d square equal to minus 4, then d equal to plus or minus square root of 4. We know whenever we are taking minus from under square root, it will become j, then plus or root of 4, square root of 4 will become 2. So, we obtain that two solution, one is d plus 2j, another one is d minus 2j, or we can simply say the two roots are minus 2j plus 2j. But it is what it is. Sir, so far we saw only real values, but here we are having purely imaginary. How can I write the solution for that? See, in general, let me tell you one thing. We understood for real roots how to write down the solution. Whenever you are observing complex roots, this is imaginary, purely imaginary. Complex roots means it will be the combination of real plus imaginary. See there, here alpha indicates real part, beta indicates imaginary part, you can observe here. So, alpha is real part, beta is imaginary part. So, when your roots will be in the combination of real plus imaginary, always while calculating imaginary roots, whenever you are trying to find out the imaginary roots, you will be having pair roots. Definitely pair of roots will exist. You will be having two roots, one will be in plus, another one will be in minus, that's all. But definitely you will be having pair of roots. Pair means two roots. Two roots will be having same values, but sign will be different, plus minus. Okay, sir. So, whenever you are observing complex roots, complex means it will be the combination of real plus imaginary. How to write down the solution? Only step is just you know how to write down this one. We have x is independent variable, y is dependent variable. So, dependent variable is depending on independent variable will be equal to, first write down exponential term, in the power of exponential term substitute the real part of the root, real part value, just only one exponential term. So, e power alpha times of here, how this x is existing here, x is our independent variable. After that, always standardly write arbitrary constant a, arbitrary constant b in addition. In case of real roots, we will be writing exponential term like this, but here what you have to do is multiplied by cos beta x sin beta x, where beta indicates imaginary part. See, this equation is fixed. Whenever you are observing complex roots, complex means it may be a purely imaginary root or it will be the combination of real plus imaginary. In our case, we got purely imaginary only, but I am generalizing it. So, always just write down this expression, keep it in your mind. Write down one exponential term. In the power of exponential term, we will be having two things. One is real part of the root value, only one time. After that it will be multiplied by the independent variable. Similarly, after that in the bracket write down two arbitrary constant in addition. After that first arbitrary constant will be multiplied by cos beta x, second arbitrary constant will be multiplied by sin beta x, whereas beta will be the indication of imaginary value of your root. That is all. Now, if you observe in our case, we will be having only what? Imaginary part. It means it can be rewritten as 0 minus 2j, again 0 plus 2j, or I can combine this, d is equal to 0 plus or minus 2j. See there, now it is in the form of alpha plus or minus j times of beta, whereas the value of alpha equal to 0, value of beta equal to 2, that is all. Now, go to your expression. Here is our generalized expression. So, in place of alpha, observe this step. In place of alpha, we have to replace it by 0. In place of beta, we have to keep 2. After that, see there, we know e power 0x will become 1. So, we will be having only a times of cos 2x plus b times of sin 2x. So, this exponential term will not appear when real part will be 0. This exponential term will appear only when real part is not equal to 0. That is all. So, that is how we are obtaining complementary function. See, beginning of this there is a proof how we are obtaining all these things. But in this series I do not want to cover anything blah blah, because there are so many things, resources are available. You can go through even YouTube itself. There are so many faculties who have delivered all the concepts step by step. NPTEL lectures are there, standard textbooks are there. The only thing is, after learning all these things, still we are struggling how to solve the questions. That is why here I am delivering all the concepts directly through problems. Now you will be able to understand these all are gate questions only. These questions are already asked in your examination. Now when you are learning directly through the question, when the moment you are observing this type of questions in the examination, there is no point of thinking how to apply the concept, because you are learning concept through problems only. Directly you will be able to solve whatever the question exam it is. It does not matter whether you are from USA or you are from UK, it does not matter. You can directly solve all type of question, right? Fine, sir. So now we understood how to get the complete solution for this. I am giving one more example, homework question. Take this one, try to obtain the solution for the given expression, right? So don't forget, step number 1, obtain the roots. Step number 2, if it is the complementary function, then you have to write e power alpha x plus a into cos beta x plus b into sin beta x. After that you will be getting the answer. Okay, sir. This is all for this lecture. In the next lecture, I am requesting you to come up with the answer for this question. Anyway, I will be giving the solution. Thank you all.